When one thinks of the subject of nuclear science, one might think of the nuclear bomb or Chernobyl. They'll think of destructions and explosions. Of course, in reality, this chaos is rare. The subject of nuclear science is one of beauty. It shows how powerful we humans have become, and it shows that we harness the power of God/gods. We can use this power to destroy or to create. It's up to us. However, this power is quite complicated. It doesn't happen with just a push of a button. It happens when the circumstances are made right. It should be the perfect temperature, the perfect amount of nuclear fuel, etc. One small misstep and the chaos I mentioned earlier will happen. In this short video, I will be giving you a nutshell of how nuclear science works. Firstly, we should answer the question of how. How does this work? There are two primary types of reactions in nuclear science: fusion and fission. Fission is the power we currently know how to properly handle. Fission begins when a neutron goes very fast and hits an atom. This atom would end up splitting into two or more atoms. It would also release more neutrons, which would continue the chain reaction. Fusion, on the other hand, is when two atoms come to become one bigger atom. Usually, it would be two hydrogen atoms fusing into a helium atom. The thing about fusion, though, humans are a bit too weak to harness it peacefully. We're still studying it, but currently in 2021, the only thing harnessing fusion in a peaceful manner is the sun and the stars. But we'll get there someday. We did in the case of fission. Note, fusion is more powerful than fission. Humans started harnessing nuclear power in 1942 when we created the first fission reactor. Wait, hold the tape. What's a reactor?
A few moments later.
Alright, reactors. They're a way we generate electricity, just like windmills and dams. The cool thing about reactors is how efficient they are. It works something like this.
This is the launch of a nuclear reactor and the beginning of a thermonuclear reaction. This blue glow from a nuclear reactor is called the Cherenkov effect, in the name of the scientist who first explained the effect of this phenomenon, but I'll talk about it later.
So we need a lot of things for a reactor. We need the building, the fuel rods made of uranium, a huge water supply, turbines, generators, and boron rods. These are the basic parts of an average nuclear reactor. If you place a radioactive material like uranium next to another piece of radioactive material, you will get the beginning of fission. While we do need to get the room at the right temperature, it's a step in the right direction. The room should be hot enough for a single atom to split. The separation would cause two smaller atoms and a neutron to take their place. Neutron hits another atom, beginning the fission chain reaction. Each time an atom splits, heat energy is released. We can control this reaction with boron, which can absorb neutrons. The rods of uranium will be placed next to each other, but between them will be boron rods, also known as control rods. The reactor operators can raise it or lower it. Raising it would generate more electricity. Lowering it will make less electricity. Now, water plus heat/fire creates steam. We've known this since we discovered fire. In the reactor room, they would fill the reactor vessel, which houses the fuel rods and boron control rods, with water. Some of that water would become steam. Steam would go through pipes and spin turbines. The turbines would power generators, which in turn would create electricity. Here's the part which shows how efficient these reactors are. One tiny amount of uranium would provide enough electricity as a truckload of coal. Yes, these reactors are expensive, but they are worth the money. Now that we covered the peaceful part of nuclear science, I'll get to the part where most people are interested: the nuclear bomb. Earlier, I said that we did not know how to harness fusion peacefully. We do know how to harness it using the thermonuclear bomb. So, we know that there are two types of nuclear reactions: fission and fusion. Just like that, there are two types of nuclear bombs. There's the atomic bomb, which uses fission, and the thermonuclear bomb, which we civilians know as hydrogen bomb, which uses fusion and fission. Remember, fusion reactions release more energy than fission reactions. In this video, we will be explaining the thermonuclear bomb, because the workings behind it are really fascinating. So, there are three primary parts of the weapon. There's the fission bomb, the fusion fuel, and the casing. It starts when the fission bomb explodes. The energy is released, which heats the fusion fuel. The fuel starts the fusion reaction. Before you know it, the casing will turn into a ball of fire. Nuclear science is no doubt an amazing branch of the subject of science. In the right configuration and in the right hands, it's no doubt a symbol of how we humans have evolved. It can power cities and countries. It can save us all from climate change. But at the exact same time, it can destroy us, turn cities to rubble, cause governments and countries to cease existence. In fact, if it's in the wrong hands, it can eliminate us all. All it would take would be a push of a button. Hey guys, thanks for watching this video. This is our first video on the browsing channel. If you enjoyed this video, please consider clicking that thumbs up button, subscribe to receive our notifications. It would really help if you could go down to the comment sections and tell us what topic we should cover next. Once again, thanks for watching, and we'll hope to see you next time.